So let's get right into it. We're going to talk about the first topic, CentOS retirement, what's the effects it had on the industries. Dave, I'll start with you. I guess being a former Red Hatter and being in the industry, you've seen a lot of things happen at Red Hat. What do you see from your perspective of what's going on with the CentOS retirement, and how does that, affect what we're doing here at Canonical?
It was actually really interesting. I was a Red Hat when that retirement was announced, and it kind of came out of nowhere, to us at least in the sales organization. So it was a very big surprise across the industry, because if the sales org don't know, then probably the customers didn't see it coming either. There's been a long history of CentOS in oil and gas specifically, and in all energy companies, because a lot of their work is built around HPC and around getting the time to oil answer faster, which HPC helps them do. As a result, they have a lot of machines. There are a lot of large HPC installations that customers were using and running. They were running a mixture of enterprise supported for head nodes usually, and then hundreds of thousands of nodes in some cases of CentOS machines, because they were essentially treated as kind of, like if this breaks, we'll just pull in another one, we'll rebuild it. And that's why that model of CentOS of, not being supported, it being downstream, was very well accepted. When the announcement happened, it was kind of interesting to see, because energy isn't normally the forefront of technology. It's normally like a little bit of a laggard. It lets other people make the decisions, or at least it was at that time. I'll preface that with this was kind of, a couple of years ago, before a lot of the pressure that we've had from COVID in the industry, forcing us to become more technology relevant. But when we looked at that, it was like, hey, how are we going to fix these problems? How are we going to use a similar kind of model and still have a way forward? And then as we get more and more into cloud, that need for support was more and more important. Those large customers, like as a real world public example, Shell is very well known for running 100% Red Hat Enterprise Linux in its HPC. But then every other company you can think of, the BP, Schlumberger, Halliburton's, they're all running a mixture of enterprise supported and full community. So there's a lot of problems need solving. I've not seen anyone that's actually fully solved those problems yet. So we're still right in the middle of how are we going to fix this.
And with the CentOS bits, so to speak, being retired, that was kind of a catalyst to be able to go from, maybe a testing in staging environment, or even the development environment, into the production and still be on the same bits. What does that mean now, and how does Canonical and Ubuntu play a factor in that?
So that's where I believe that Canonical has a leading solution, for the simple reason that if we take a quick step back and we looked at the other world, the Red Hat style world, Fedora was the upstream product. So that's a product that you could get that was leading edge, that you would have to wait for some patches, and it wasn't enterprise supported, never will be. That exists still today, right? But it's not the same bits as the enterprise product. Hardened, secured, has patching, can buy support. That in their world is called Red Hat Enterprise. Then CentOS actually, and a lot of people don't know this, is why I'm taking time to explain it. CentOS occupied a totally different position that kind of isn't there anymore at all, which is downstream. And downstream is taking the enterprise bits, removing all of the references to the enterprise product, and repackaging it as CentOS. And actually, Red Hat used to pay a lot of people under the CentOS project, fully paid, funded people to do that work. That doesn't exist anymore. So companies are looking at, how do I do this? And how do I not be bleeding edge? How do I get enterprise level product? And how do I bridge that gap where it's the same kernel, the same bits? That's where Canonical and specifically Ubuntu comes in. The product that we have is free for use. It's the same bits. So it's free for use for a period of 2 years from release. And then if you want support after that, then you pay a support contract. You can also choose to pay a support contract and get more bits and more support and more things right at the beginning. But the idea is you can, with the Ubuntu product, develop, sandbox, move into production all on exactly the same bits with zero changes, the same patches, the same security, which is getting better every day. We're doing more and more patching every day. And that's where the market doesn't have an equivalent that I'm aware of at this point.
Okay. John, from a HPC community standpoint, stepping a little bit outside of the energy, but just as a broad HPC focus, what is that retirement? What's the impact been on that?
I would say this has affected the HPC community somewhat. The full effects probably yet to be seen, as the upgrade and deployment cadence in HPC systems is quite varied between industries. But HPC users have definitely been left searching for alternative solutions. We have seen this ourselves with a high number of users looking for migration paths from CentOS to Ubuntu. The number of HPC ISVs looking to extend their platform support to Ubuntu has also risen. Other distributions have also seen growth, such as SUSE Enterprise Linux or OpenSUSE. The same goes for other RHEL derivative distributions, such as Alma Linux and Rocky Linux. All three have some confirmed growth via third-party repositories, sharing access numbers. But Ubuntu is uniquely positioned as a fit for migration from CentOS for HPC workloads. Ubuntu has an extensive list of libraries and packages, most of them quite recent versions, thanks to our 2-year LTS release cadence. This is great for the user, as running a recent kernel can in some cases deliver additional performance, thanks to kernel and driver updates. And the user might just find that his required packages are already in the repositories. And overall, Ubuntu is generally the choice of preference for rapidly evolving fields. For example, it's used extensively for workloads in the life sciences and for AI ML workloads. The latter is quite relevant for HPC based on some of the recent trends we are seeing. For example, simulations being added by machine learning, or like we are seeing in automotive, where simulations are being used to validate and test autonomous driving models.
So let's kind of let's talk about that a little bit more. James, you also do consulting and provide services in the energy space, as well as you do a lot of automotive. What have you seen as the impact?
Thanks, Sean. Good question, and I probably fall, somewhere right in line with what Dave and John were mentioning. For me, there's really a unseen benefit to kind of the retirement of CentOS and the transition to Ubuntu. I think, one of the reasons that I heard mentioned, which I strongly agree with, is a cost savings, and a level of consistency between different environments. But not every organization wants to have an enterprise support contract on their staging infrastructure or on infrastructure that isn't critical and something that needs to be 100% 5 nines uptime. And so with Ubuntu, organizations can develop, test, deploy staging environments on the identical operating system, identical configuration, and then move those workloads to production and support, under Ubuntu Advantage, only the parts that matter. This has just a positive impact in multiple senses. So I'm happy to see it happening, and I think the future has great things in store.
I think we're gonna field a question real quick. Rose, we had a question that came in. I think it's probably appropriate to maybe answer that right now with the group.
Yeah, so someone asked, isn't SUSE SLES OpenSUSE Leap exactly the same? Same bits as Enterprise, and you can transparently transition into being supported if you need it. Dave, I think you wanted to take this one.
That's a bit of to a degree, how long is a piece of string? Because some parts of Leap are more similar to the Fedora versus RHEL relationship, i.e. upstream versus enterprise, and then other pieces are much more downstream related, i.e. RHEL versus CentOS. So in some cases, yes. In some cases, no. It's not a particularly perfect answer. But the relationship comes to the patching. Like, what we really have to look at is, where is the patching? How quickly do you get it? When is it applied to that product? That is not, there's like the SUSE product and OpenSUSE Leap is not on the same patch schedule at the same times, and therefore you always have a delay. Sometimes you might have a product that's not fully accepted in the upstream. So the answer is it's close, but it's not an exact analogy.
Dave, I'll add to that. Something unique to Ubuntu is live patch specifically. I don't think there's anyone else out there that is doing kind of real-time kernel patching, no reboot, no downtime. This is a huge strategic advantage that companies have deployed on Ubuntu.
So someone asked, but isn't Ubuntu Advantage or an LLA or nothing option on Azure? Either you protect all VMs, staging 2, or none at all.
I'm going to take a wild guess if that's all or nothing, Rose. So on Azure, there actually are a lot of options with Canonical's offerings on Azure, especially around Ubuntu Advantage and Ubuntu Pro. There'll be some announcements coming soon that will widen those options, but we do a thing called a private offer where you would be able to work with a salesperson, create a complete custom solution for you, support what did need supporting, and so on, and kind of mix and match. So the answer is no, it's not an all or nothing, but in order to get that flexibility, you need to speak to somebody in the sales organization.
All right. Well, let's move on to the next topic, which is the transition. Right. We've identified the environment and the issues and the challenges that companies are having. But what's the plan? What's the transition? I know there's some newcomers like Rocky Linux. Let's dive into that. Let's see here. I'm going to open this question up to the group. So we know Rocky has come about as it relates to this retirement. What's the business impact in selecting a newcomer, and is it prime time? What's the perspective from the HPC community? And how does this change the core operating system and configuration outcome of the results and I guess you'd say predictions that these systems are creating? Is there a concern for that?
I'll take a stab at some of this. So I know a lot of the guys in the Rocky project, good set of people, very, very good at what they do. The fact remains, nothing's really changed from CentOS to Rocky in terms of how that operating system is being crafted, which is taking the Red Hat Enterprise Linux product, stripping out all of the stuff, replacing it with a different word. So instead of, control, find, replace CentOS, now Rocky. It remains a downstream product, which means you are at risk from getting, a longer lead time to support. Sometimes that's not a risk that's like a bad risk, sometimes that's acceptable. My kind of primary thought on that is, and the Rocky Foundation have said they're very committed to long-term support. But from a pure business perspective, I'd want to know if that was sustainable, because it was being funded in large part by Red Hat. And now it's not whatsoever. So at some point, the money may run out, and then we'd all be in the same scenario. If I was an IT user and I went to Rocky, I'll be like, okay, great. I've got the same thing as I had in CentOS. But then what's going to happen in 2 years or 5 years or whatever? Like, am I secure? Do I have a proven track record? Is it going to be the same? Is something going to happen and then it'll go elsewhere? I really don't know the answer to that question. And I'm not trying to sow like kind of uncertainty and doubt, but there is some uncertainty and doubt. So from my perspective, I'd look for what's the most sustainable, long-term, proven product.
Yeah, that was a great answer, Dave. From my perspective, I see that downtime, from like a solutions perspective, from an SRE perspective, like avoiding downtime is kind of number one. We all know that. And, I don't see anyone switching to Rocky, to tell you the truth. I know there's probably people out there, but I see people moving towards Ubuntu, to tell you the truth. We have some simulations that, run just faster on Ubuntu. And for what reason, be it like the newer drivers, newer build chain software that's supported against kind of the latest and greatest can take advantage of some of these things through Ubuntu. Like unforeseen, to kind of dive into the downtime, unforeseen degradation or downtime of services can negatively impact time to market. There are definitely advantages in using an operating system that it has a good support contract behind it, like Ubuntu Advantage. It's on that note, I think it's really exciting to see Ubuntu stepping into the HPC space for this reason.
So that's a good comment about performance and drivers and stuff. That would be, from my perspective, that would also be another concern for me in that transition. If people are, looking at Rocky as a solution, is there going to be drivers? I mean, is NVIDIA and AMD and some of the others that are producing, GPU capabilities, are they going to support? Or are they going to, are they waiting to see what happens? And is Rocky the stopgap while people figure out what's going to happen? John Thor, if people are looking to transition to a new core operating system, that's one thing. But rolling it out, if someone says, hey, I'm moving from CentOS, I've made a decision, I'm going to go to Ubuntu or whatever the operating system is. It's always a big challenge to know how to do that and do that efficiently. And rolling it out to thousands of systems is not a weekend job. So what are some of the things that companies can look to do to make a transition?
Well, absolutely. Great question. So MAS is a great solution in the cluster provisioning space. It has capabilities that far surpass traditional cluster provisioners. And best of all, it's very user-friendly and gives an excellent overview of cluster resources via its excellent UI. MAS also has an extensive list of provided images, and we even maintain an open source repository of a good set of unofficial images. So it's quite likely that you might be able to find the right image for your use case, whether it's be Rocky or Alma or whichever it is. But MAS delivers a cloud experience for bare metal servers, and MAS combined with Juju is excellent when it comes to deploying, maintaining, and operating the applications that make up your cluster setup. So definitely do consider MAS for this use case.
There are tools today that I know you're spearheading a lot of this, John, that we're using with multiple other large customers that will allow you to look at what are the dependencies, what are the packages you need, and which version, and make that translation if needed. A lot of those is, it's not needed, but there's tools out there that help you do that, right?
Correct. Yeah, we're working with the field engineering team to be able to basically create a roadmap, right? To do that manually is quite a task. So we're doing some automation tools to be able to provide that migration map, and also provide some of the heavy lifting where we're actually creating the images on the fly for testing and validation. So those things are great ways to engage our field services team, engage Canonical to help with that migration. Okay. Any other? Do we have any questions coming in?
Yeah, a couple. So Jason asked, how can I obtain more information about enterprise support? So Jason, we do have two different avenues you could go. I mean, so you could go to our website, ubuntu.com/support, and there would be a chat box where you could talk with one of our people live at Canonical and get you some help. But you can also scroll to the end of that page, and there is a contact us button where you can fill out a contact form and let us know what you've got going on. But yeah, so that's ubuntu.com/support. We do have a couple questions. What do you think the impact of running K8s? Would it be more stable to run on something like Rocky rather than Ubuntu? Or do you feel it's more stable on Ubuntu because it's generally running new kernels? John, Thor, I think you wanted to take that one.
I will definitely say that it could deliver a great experience. I mean, I will consider looking at our charmed Kubernetes distribution or microkits even to test it out. It's been very, like, we have seen a lot of growth in the usage of Kubernetes on Ubuntu, and workloads that are predominantly run on Kubernetes are quite strong on Ubuntu. So it's definitely somewhere the community has been looking.
I believe it gets even more interesting when we look at HPC specifically as well in K8s, because there's always going to be some kind of parasitic loss when you start containerizing a workflow that used to run on a bare metal machine. However, we can add scale to that now, and we're also creating a solution. John and I have been working this for a little while with combining K8s and MAS and Charm Kubernetes specifically, and then also LXD, which gives you much faster, better performant access to that hardware in a more virtual machine style form factor. So by combining all of those into your ideal solution, and we can use things like MAS to absolutely fully automate it, Juju to fully automate it, you can then find the best kind of workflow and the best platform for your use case and just make it happen for that use case and seamlessly move between, if it was better in containers or it's better kind of virtualized, you can seamlessly move your hardware between those now, which is something that is also like getting to be very unique. A lot of people are just straight to the cloud. We can do straight to the cloud plus all of this stuff in the middle.
Yeah, and I want to touch on something, and I know, James, we're going to talk about it in our next topic, but we mentioned Charmed Kubernetes. Charmed Kubernetes is driven by our orchestration framework Juju, and that has a tremendous amount of power in facilitating transitions to other technologies and orchestrating new environments. Leveraging with MAS to be able to bring up an HPC environment and then bring up a Kubernetes environment, as well as what I'd say, charming your own applications or your own set of HPC code to facilitate lifecycle management orchestration. So that's a very interesting topic. We probably have a whole webinar on that alone. But I know, James, we're probably going to touch on this a little bit in our next section. But that's a very interesting topic to go over. And if there's anybody that's interested in that, please post a question. I think we've done some webinars in the past, but very, very interesting in technology from the standpoint of orchestration at a higher level. Any other questions we have coming in?
Yeah, we have 2 left in this section. So
Okay.
Someone asked, the bank I work in Brazil uses CentOS 7 until today. Should we be concerned about this closure? Dave, you want to take that?
So the CentOS 7 does have an end of life, which is June 2024. So you have a little bit of time. You need to find a solution before that, because as of that date, there will be no more support, no more patching, no more security. Like it's done at that point. So do you need a plan now? I believe so. It's much easier to do it when you're not under pressure. So there should be some concern, and I would be surprised if somebody, wasn't looking at that. But that for sure is not a long-term way to, especially banking, where Brazil doesn't have to follow the same rules as the US, but there's a lot of security and rules around that from a government perspective. You need to be looking into secure operating systems. For example, Canonical adheres to a standard called FIPS. You need to be looking at things that are going to give you that solution in a secure way, especially if we move more and more workloads into the cloud and back out again.
We have one more. So Red Hat seems to be leaning strongly into Kubernetes and OpenShift as the platform for hosting applications like Ansible Tower. Is Canonical also taking the same approach with future products like, for example, MAS? Dave, John, Thor, you guys want to tackle that one?
Maybe there's some clarification. Because in my experience, you would use, it doesn't really matter where you host Tower, right? As long as it's hosted. So you could absolutely host it inside a container. But I'm wondering if that's also a question on that container platform then being managed by Tower. Because that seems like the larger question, right? Like, are we looking to do that? And I think John Thor's absolutely the right person to answer that. But we are indeed taking that, solving the entire problem with a solution, insofar as a combination of Maz and Juju, Charmcakes, LXD will do everything for you, landscape, live patch. You add all of those together, you have a much more robust answer than just the OpenShift with Tower. John, go ahead, take it away.
Yeah, so in terms of Maz, like Maz is very much our bare metal prisoner, or a way to basically deploy bare metal clusters, bare metal resources. But it does definitely integrate quite well with automation frameworks like Ansible or Terraform, or for what we are focusing on, Juju. So basically, Juju can be used to basically deploy resources, whether it's be Charmed K8s or Charmed Kubernetes, Charmed Slurm, like the solution from Omnivector, or any of the other Charmed solutions we offer. They can basically be deployed kind of against Maz, operating as kind of a cloud for bare metal resources, enabling easy delivery, deployment, and operations.
Yeah, and I think in most cases, the solution stack that we offer is, again, it's open source. It's free for everyone to use. I think there's some slight limitations on custom images and Maz and so forth, but for the most part, it's again, you can deploy, test, do validation in an environment that's, technically, you don't have to have the enterprise support like James was mentioning. You can take that same solution and then run it in a supported environment. And that's, not everyone can say that, right?
If I might, yeah, that's a great point, John. And, to run with that for a minute, I think that, Juju is a great thing for many reasons. One thing we do with it is it allows us to repurpose infrastructure almost immediately. So for some situations where you might want to use that high performance compute hardware to accelerate your model training. Let's say maybe you want to use the high-speed fiber connects and GPUs contained in a set of your HPC infrastructure to accelerate your model training. And you want to do distributed model training using MPIs. It honestly just takes up a few moments to move one of those pieces of bare metal infrastructure from an HPC, a traditional HPC system, into your a group of Kubernetes workers. And so then, with very little friction, we have been able to kind of, take advantage of some of this hardware, HPC hardware, to perform our AI/ML workloads on as well. And the lack of friction there is what's most important. Being able to take that piece of hardware over, repurpose it, and get the value out of it in a different context is almost unheard of. So I'm going to say, power to that. And, for people who are looking to do AI/ML using HPC hardware and get that, speed up in their model trainings, we'd be glad to talk to those people and have a further conversation about this.
Yeah, and I think we kind of we transitioned a little bit into topic 3, didn't we? Which is, HPC, AI/ML. What are the big challenges? James, you kind of alluded to a couple of things, but I'll jump over to John. What do you see HPC and AI/ML? What are the different challenges they have, and what are these companies doing to solve them? And is there any effects that you see in the industry relative to CentOS and the retirement?
Yeah, so in many ways, HPC and machine learning share a lot of similarities, especially when it comes to running these workloads at scale. Machine learning has, of course, historically been run primarily on GPUs and other accelerators, while HPC has traditionally been more CPU intensive. But we are definitely seeing more of a mix there these days. But overall, both workload types require a very similar set of expertise and enablement when it comes to running these workloads at scale. They generally require high-speed networking, computational storage, scheduling, and workload management.
James, you kind of alluded to that, different types of workloads, and there's kind of this great divide but convergence, and some of the things that you're doing are kind of solving those problems. You want to kind of dive deep into that, or not dive deep, but kind of give us your insights and what you're doing and how that infrastructure and ecosystems are being impacted.
Yeah. So, just kind of from what I was just talking about, the from a software perspective, we want to be able to kind of well, let's say this: if you're deploying your HPC systems with Juju, and you're also deploying your AI/ML systems with Juju, that gives that's where you receive the biggest benefit, because you get interoperability between the two workloads from an operations standpoint, which is really, really important. When we now need to, and to touch on what John was saying, using these high throughput fiber connects and GPUs of the HPC systems to help accelerate solutions in the AI/ML space. There's one thing, one piece of software from Kubeflow. It's called MPI Job. I think it's still in alpha, but we've seen a lot of kind of uptake and a lot of interest in MPI jobs in Kubeflow. MPI job is basically a Kubernetes resource a custom resource in Kubernetes that allows the GPU and the InfiniBand card to be passed through to the container. And this way, organizations who are using Kubeflow to perform AI/ML workloads can take advantage of the underlying hardware and run a type of distributed model training called MPI job. So, like I said, repurposing the HPC infrastructure to facilitate AI/ML use cases takes less than a handful of commands at the terminal in just a few moments' time. We're able to automate and create process around this such that infrastructure engineers can easily move resources from one to the other and, right into their Kubernetes cluster on a supported version of Ubuntu and supply that value to people doing AI/ML in their organization.
So James, being we're all a little bit biased, right? Because we're Canonical. We work for Canonical, but you have your own organization. You consulted on different technologies, and you actually have built a product that you're about to release, leveraging some of the Canonical technology. Why Ubuntu? Why did you choose Canonical? Why did you choose Ubuntu? Why did you choose Juju as an orchestration framework?
I love this question. Thanks, John. So, for us, it was pretty simple. We needed to support CentOS workloads and Red Hat workloads and Ubuntu workloads, all within kind of the same sort of infrastructure. Using Juju in combination with Maz, we were able to write a set of Juju charms that allowed us to deploy these heterogeneous HPC systems. And so for us, and for many of our use cases, it's very important to sometimes you really have to drive with the use case here. And some vendors of HPC software may just support Ubuntu. Other vendors may support only CentOS. Other vendors may support Red Hat. And so being able to have a HPC cluster that has heterogeneous partitions, some partitions Ubuntu, some nodes running CentOS, and some running Red Hat, is it's been invaluable for us to take advantage of this type of automation and interoperability between systems that kind of comprise the the workload manager itself. So the automation that we put a lot of time and energy into is called Slurm. You can find it in the Charm Hub, in the Charm store, and it's freely and openly available. Anyone could pull down the software and deploy it and have themselves an HPC cluster in a few moments' time. So feel free to check it out if you haven't yet. And, we're here to answer questions if anyone has any.
Yeah, very cool. And then your link to your website's also in the links and resources, Omnivector Solutions. And again, you're releasing a product here, probably Q1 of 2023, that helps also provide some additional management and orchestration of HPC environments and Slurm, if I'm not mistaken.
Totally. Yeah. Thanks, John, again. And so to that effect, it's using the automation that we've created, the set of Juju charms that deploy Slurm. They're very powerful in the sense that we also, not only do we have interoperability between, partitions of the cluster that run different operating systems, but we have interoperability between partitions running on different substrates. So, we could run a partition in the cloud, or we could run a partition on site, or a mixture of the two. Let's say you have an open stack in one section of the data center, and another team has a VMware Sphere cloud, and let's say you also have an AWS cloud that is reachable from your private networks. Using Juju and using our Slurm software, we could deploy the HPC workload manager kind of across any number of substrates and basically allow engineering teams to run workloads where it makes sense, using one workload manager and kind of one deployment system, bringing in the consistency here for the win. The whole thing has seemed to be a really good experience. So our product allows a user to kind of choose a cloud of their choosing or their own on-site infrastructure and kind of mix and match where the workloads run using the web-based HPC platform that we've been developing at Omnivector. So, in the near future, Q1 2023 is kind of our anticipated go-live date. We're going to make this publicly available and allow, anyone who's willing to sign up and sign in the capability to stand on top of this automation.
Very cool stuff. All powered by Juju. Not all of it, but a lot of it. So if you haven't checked out Juju, you can check that out on Ubuntu's website. Very, very cool stuff. Got one last question to Dave Montana. In NVIDIA, with all of these, migration strategies and plans, in HPC, AI, ML, NVIDIA is a major player in that. How does that impact companies' migration plans with their investment in the space?
So they are getting, from a enterprise perspective, pretty much these days the most important player in terms of computational business, right? In the old days it was the CPU guys, and we're really seeing this massive shift over to GPU compute. So we absolutely need to, and HPC, we're a little bit kind of, still on the CPU world, and we're gradually transitioning, but then there are other people in the AI ML that are like, hey, we need nothing but bunches of graphics code. So we need to be able to support that at a very intensive level. And that's what we've done here at Canonical is we've engaged with NVIDIA. We now are the operating system for NVIDIA's internal business and, for all of the products that run their AI ML stuff, like you buy a DGX, comes with Ubuntu. If you go buy some of the new the new NICs, like the smart NICs, comes with Ubuntu, et cetera, et cetera. That makes it a very easy transition for somebody to be able to use that. And we're working heavily with NVIDIA to do two things that I think are valuable for the industry. Number one is kind of modifying our products and our kernel and whatnot to make that more performant and to make it the best in class, because we can do that, right? Now, if you don't own the operating system as such, you can't really do that. But we have this ability to influence, and we kind of, own what we support, and hence we've been able to do that. The other piece is NVIDIA have engaged us in a really interesting kind of route to market, which is around secure open source supply. So they basically came to us and said, hey, here are 4,000-ish applications that we consider like a priority one that everyone uses for, and these are all open source apps, that everyone uses for AI ML, like this kind of the big list. We'd like those to be supported, secure, able to be easily deployed, like one-line deployment through Ubuntu. And that's what we're working on right now, and what we're kind of very quickly developing is this ability for you to be able to take supported, secure product, open source, install it on your Ubuntu operating system or your platform, like your Canonicals, Charmed Kates, or whatever, LXD and all that kind of stuff, and then talk to that graphics card in a very, very quick, very efficient way, as well as being fully supported. So for me, it's fundamental, because now we can give people better performance when they're doing GPU-related work. And that goes across compute into visualization as well.
So, yeah, so companies need to obviously you need to look at your technology stack and know how to future-proof, so to speak. But when you look down that telescope, understanding where your main compute and computational is going to come from, that's an important factor to think about, especially as new operating systems are being born and new flavors is what's ultimately going to give you the most, the best performance and the best results from supported players.
That's where Mars really shines, right? Because in some cases, we're in this transitional phase in the HPC world, especially in energy. And some things are better bare metal. Some things are better containerized. Mars gives you that ability to very, very easily, quickly, and without fault, deploy that and go, hey, now I want that same piece of hardware to be container platform. Oh, okay, I'm finished with that. Now I want it to be bare metal. And that's absolutely, kind of world class in terms of how it's done with Mars. And it's very, very easy. If anyone remembers like the old days of OpenStack Ironic, where like, I think that's why I have no hair. Mars is a completely different, better product, and it does everything seamlessly.
Awesome. We've got 10 minutes left. I'm going to kind of just open things up a little bit. What's next? What's the big thing that, from an HPC standpoint that companies are looking at, or things that are changing that could make a huge impact in the community?
I'd like to think that what we're doing makes a pretty big impact, to tell you the truth.
I think so.
So, check out the Slim Charms. Like I said, I'm willing to have a conversation myself with anyone who's interested in them. And our engineering team would love to support, people who are interested in checking out the stack.
One of the big things I see, and this supports James's statement as well, is I'm seeing a lot of interest and a lot of push. And actually, James brought it up in MPI jobs as well, is the containerization of HPC workloads. 4 years ago, everyone was like, no, never going to do that. And now we've realized we can make better, more efficient use, and we can oversubscribe in some cases, hardware capabilities and pull them from different spots and be more flexible, because now we can go to cloud, we can come back out of cloud again very seamlessly, losing containers. If I'm a provider of HPC services, I want to get an answer faster. It'd be really cool for me to be able to very seamlessly go, tell you what, give me 20,000 more instances for a couple of hours on this cloud provider. Give me that answer, bring it back, and then I'll do the rest in-house. So we are absolutely seeing a move towards containers being a key player, whereas, very recently, people would have said absolutely not, never.
I would definitely, to add to Dave's point, I mean, yeah, we're definitely seeing containers. We're definitely seeing like easy build and Spark, to kind of simplify building. What I think is the like main theme here is like trending towards making things easy, like easy delivery, making clusters easy to provision, just simplifying things, like not overtune our systems or not like spend years deploying them. Let's get things up and running. Let's do the computations in a way that's, preferably also repeatability. The containerization has also driven that, like being able to kind of take a workload, run it, expect the same results because you actually have the application and everything's surrounded in it in kind of pre-packaged format. So I think these are kind of the two big trends here.
Now I know there's been to add on to this, the HPC on Kubernetes, is a huge, we talk about containerization, right? Containerization means a lot of different things, right? Because you can containerize from the OS perspective, using LXD for example, but then you have containerization from an application standpoint, like a Kubernetes, right? And really Kubernetes was designed for the orchestration of applications, but people are seeing this as huge valuable tools to orchestrate, to roll, to do updates, or is a HPC or a node dies, it regenerates itself and so forth. But again, Kubernetes was designed for application orchestration. It wasn't necessarily designed for HPC type workloads where you're dealing with tens of thousands of systems. What's the answer? I know there's MP, people have talked about doing MPI on Kubernetes, but what is the answer to that?
I think in terms of Kubernetes, I mean, sure, it's quite not there. I mean, it currently lacks queuing, gang scheduling, batch scheduling, really. It's all these features that are kind of vital, like vital for HPC workloads. So it's not there, definitely. But there's definitely development taking place there. That's very interesting to watch and follow.
Yeah, and John, Thor, you and I we're actually actively working with some energy companies, and putting together a technology stack that we think from a implementation standpoint to get that Kubernetes type feel, but without some of the limitations that you have of the control plane. And that's something that you and I are working on, because we see the want, but we got to make sure that we give the results that these companies really need, and not be limited by some of the limitations of Kubernetes. James, you had a couple of comments.
Yeah, we support oversubscription in the Omnivector Slurm distribution via containers or not with containers. So there's a technology out there commonly used in HPC. If you want to assume a container workload, if you want to assume like a container delivery mechanism for a HPC workload, there are multiple technologies out there. One that we are very familiar with is called Singularity. Singularity is basically like a container manager that gets installed on your HPC cluster and allows you to run your traditional HPC workloads, but assume like a kind of a packaging delivery mechanism that is common container workloads. So, with Singularity and Slurm, organizations can easily get this benefit of delivering the bits the way that we want to deliver them now in the modern day, and then using those bits how they're used to using them with the different scheduling and kind of resource scheduling that they're used to with traditional HPC systems.
Great. Well, I just want to thank everybody. Thank our panel here. Thank everyone in the audience that took the time to join. Hoping that it was some good information. Again, our links and resources to some of the technologies and additional white papers and webinars talking about the migration paths for CentOS and HPC. I hope everyone has a good rest of the week, and we look forward to seeing you guys again. Thanks, everyone.